Welcome students. Today I am going to demonstrate a practical to compare EMF of two different cells using potentiometer in this virtual platform. Students, आज हम इस virtual platform पे दो different cells के EMF को potentiometer की मदद से compare करेंगे. So students, first मैं इस वर्चुअल स्क्रीन पे दिए गए कंट्रोल्स के बारे में बताऊंगा. उसके बाद सर्किट कनेक्शन करेंगे और उसके बाद जैसे हम जानते हैं कि EMF ऑफ सेल 1 डिवाइड बाय EMF ऑफ सेल 2 दैट इज इक्वल टू रेशियो ऑफ टू बैलेंसिंग लेंथ L1 डिवाइड बाय L2. L1 इज द बैलेंसिंग लेंथ फॉर सेल 1 एंड L2 is the balancing length for cell 2. So students, let's get started. So here on this screen we can see the controls. We can select two different cells for which we have to compare their EMF. First, select the first primary cell is written here. You can select Lachlan's as well as Daniell cell and also select second primary cells from here, and you can set the resistance of rheostat from here, and we can see the circuit diagram. So this is all about circuit diagram, you can see. And now we are going to connect according to our circuit diagram. So I connect battery to key to this key is K1 to ammeter, and ammeter to rheostat, and rheostat to potentiometer point Q, and next potentiometer to this battery. So this is how I completed first loop, that is potentiometer loop. Now I connect first primary cell circuit. So first I select secondary primary cell, that is Daniell cell. Here we can see the change in color of secondary cell. Now I connect first primary cell, that is Lachlan's cell, to the point P of potentiometer, and then another terminal to two-way switch. This is our two-way switch, and switch to this resistance box to this galvanometer, and galvanometer to I connect jockey. Next I connect secondary cell, that is Daniell cell that I have selected, and I try to connect it to potentiometer bus. First I think I have to connect it to K. This terminal is connected with two-way switch, and now this terminal is connected with potentiometer. Now I can insert the key and start taking readings. So first I insert this key K2, and then I have to select one path from key K2. But first students, you cannot change the rheostat from there. You can set the value of resistance from here. I have set to 3 ohm. Now I insert the key. You can see the reading in ammeter. Now again I have to select one of the way. I have selected first Lachlan's cell from by using this key K2. Now I am going to find balancing length for it. So first I find L1, that is the balancing length for Lachlan's cell. Now galvanometer deflection is 0, so I note down this reading 809.5. That is my balancing length for Lachlan's cell. Now I inserted key in second way, that is for Daniell cell, that is my secondary primary cell. Now again I am going to find out the balancing length for it. I need null deflection in galvanometer, so I am trying to achieve it. Yes, I am near to it, and yes, this is 583 centimeter is my second balancing length, because galvanometer is showing null deflection at this point. So 583 is my L2. Now I find out the ratio. Actually we have given Lakeland cell is 1.5 volt, Daniell cell is 1.08, but I have to compare it with our practical results. L1, that is 809.5. okay, this is my first balancing length, L809.5 centimeter for Lakeland cell, and I divide it with L2, that is 583 centimeter for Daniell cell. So I find out the ratio 1.388 experimentally in this virtual platform, and that is also verified using the value already given, that is for Lakeland cell that is 1.5 volt, and Daniell cell it is equal to 1.08 volt. So we compare it with the given values, that is 1.5 divided by 1.08, and that is also same, that is 1.388. It means E1 by E2 is equal to 1.38, means E1 is equal to 1.38 times E2. जो हमारा Lakeland cell है उसका EMF 1.38 times the EMF of Daniell cell, that is E2. That is our conclusion. Thank you, students.